Hello, everyone. Today we will discuss the motion simulation of a robotic arm. As a crucial component of industrial automation, the design and simulation of robotic arms are essential for enhancing production efficiency and accuracy. Next, we will cover the following topics. Learning objectives. 1. Learn how to create rigid bodies, joints, and constraints for physics objects. 2. Master the method for creating gear couplers. Now, let's look at the specific operation steps. We will start with a demonstration of the specific operation steps. Open the case model, select the application, find the panel of design, choose More, and click on Mechatronics Concept Design to enter the MCD module. Select Physics Navigator on the left side of the Part Navigator to enter the MCD Modeling module. Next, we will create basic physics, joints and constraints, and couplers, and finally create sensors and actuators to complete the motion simulation of the robotic arm. From our previous analysis, we know that the motion of the robotic arm consists of 5 components: the gray base, the blue slide cylinder, the gray rotary cylinder, and the blue left and right clamp holders. First, we will create rigid body. Select rigid body, and choose the gray base to create it as a rigid body. Click on the gray part in sequence. Select the base and create it as a rigid body. To complete the creation of the rigid body. Next, select the blue slide cylinder and create it as a rigid body. Click on the blue slide cylinder and create it as a slide rigid body. Then click Apply to complete the creation. Then, we select the gray rotary cylinder body, click on it in sequence, rename it to rotary cylinder body, and click Apply to complete the creation. Next, we will create the left and right clamping blocks. Click on Left Clamping Block, rename it to Left Clamping Block. And click Apply to complete its creation. Similarly, create the right clamping block by selecting it, renaming it, and clicking OK to finalize the creation of rigid body. After completing the creation of the rigid body, we can select the rigid body color to check if any parts were missed or selected incorrectly. We can see that this part is the base, which serves as a fixed joint and remains stationary during motion. The gray part is the slide cylinder body, the green part is the rotary cylinder body, along with the left and right clamping blocks. We confirm that the rigid body have been created correctly and turn off the rigid body color display. Next, we will create joints for the rigid bodies we just created. Choose the basic joint under the basic joint category. First, we apply a fixed constraint to the fixed part of the slide cylinder by selecting Fixed Joint. The select attachment is the base. Clicking Apply to confirm, and completing the creation of the base's fixed joint. Next, we will create the sliding joint. The select attachment will be the slide cylinder, and the select base will be the base. Observing the current state, we see that the slide cylinder is at its upper limit position. Therefore, we choose its vector direction to be downward and click Apply to complete the creation of the sliding joint between the slide cylinder and the base. Next, we create the rotational motion between the sliding table cylinder body and the rotary cylinder body by selecting hinge joint, with the select attachment as the rotary cylinder body and the select base as the slide cylinder. Specify axis vector. Here, we can choose the cylindrical outer surface of either the slide cylinder body or the rotary cylinder body to obtain its vector. We specify the vector and anchor point. We see that the arrow points inward, so we can reverse the direction of the vector for the hinge joint. By clicking Apply to complete its creation.